be using the Keysight N1055A 50 GHz modules to make the 4-port S-parameter and differential measurements for this transmission line. The DVT40 40 GHz GigaProbes will be connected to the N1055A modules and is used to acquire the differential TDR waveforms. To acquire both odd and even waveform measurements to extract full differential 4-port S-parameters, we attach the inline ground collar to the end of the probe to form a ground signal configuration necessary to create an S4P touchtone file used to de-embed the channel interconnect path.
The purpose of our measurements is what we're going to do is characterize a differential channel, and then we're going to make impedance and S-parameter measurements that will allow us to then create an S4P file of the differential channels so that we can de-embed it and move our reference point up to the point where, let's say, the processor I/O would be. So today I want to show the system we're using here. Here is the N1055A Keysight TDR system, and this can be used either by connecting the DVT40 GigaProbes directly to the TDR modules directly. Either you can use it differentially or single-ended. But today we're going to have them set up so that we're going to do a probe to connector measurements, which is very similar to how a test board would be set up physically. Now we have on the left-hand side we have the differential DVT40s connected to a set of manipulators. We have the 50 gigahertz TDR modules directly connected to the probe, and then on the opposite end of our trace there we have the other set of TDR modules connected to the connectors. So we're going to be characterizing and making impedance and S-parameter measurements of that differential trace. So that's our setup, and what we've already set up just to save us some time is we have the 100 ohm measurements on the display of the N1055 Keysight instrument. You can see the probe making contact there, then you've got your 100 ohm transmission line, and with cursors we can make measurements of the entire structure. Then we can take the TDR TDT measurements and then convert that to S-parameters. And here's the S-parameters. There's our STD11, STD21. As you can see, they're in real time. And then from the S-parameters, we can then save them off as an S4P file. Export that, select all. And now we've done it. Now we've saved those off onto our system that can be accessed by a working group, or we can put those onto a memory stick for use in another area.